Good morning, students. Previously we have done the what are the types of energy, kinetic and the potential energy. Today we are studying about derivation of the equation for the kinetic energy. Okay, now for the kinetic energy we have to consider a body. Okay, what we have to consider? We have to consider a body of mass. Okay, initially the object is in rest. Okay, so we can consider that initial velocity would be considered as 0, and after it is displaced the velocity changes to v. Okay, now due to changes in the velocity we can consider that the acceleration can be considered as a. Now first of all you have to consider what is the meaning of kinetic energy. Kinetic energy, we know that it is the energy possessed by the object when it is under the motion. So when the object is under the motion, you can say that the object is having the kinetic energy. Okay, so what you have to conclude? Consider a body of mass small m which is moving with the velocity. Okay, here the initial velocity it is 0 and it is displaced, so the velocity changes to v, and the acceleration acquired it is a. So today we are doing the derivation of the kinetic energy. If you see that according to work done, what is the formula? It is the product of force and displacement. So the force we are denoting by F and the displacement we are denoting by the S. Okay, so according to work done, W equal to F into S. Now next we are considering the Newton's second law. We know that according to Newton's second law, F equal to m into A. Okay, what is F? It is m into A. So when you substitute this value, we know that F equal to W equal to F into S, and F according to Newton law it is m into A. So substitute this value F into this equation. So when you will write here W equal to F into S is there, in place of F what you have to write down? M into A and S. Okay, what we are doing? F equal to m into A and W equal to F into S. So what you are doing? You are substituting this value F, m into A here and S. Okay, now the next we are considering the Newton's third equation of motion. Now according to Newton's third equation of motion, we know that v square minus u square equal to 2as. So when you separate out s, you will be getting v square minus u square upon 2a. Okay, so again we are using this equation where you have substituted the value of f, that is m into a. So W equal to m into A upon S. Okay, so when you are writing this equation again, W equal to m multiplied by A into S. So here S value we can see that it is v square minus u square upon 2a. So substitute this value here, you will be getting W equal to m into A, v square minus u square upon 2a. Now since the body is under the rest, the u will be considered as 0. So this term will become 0. We are separating 1 by 2. Here we can see here no value is there, we can consider 1, and 2 we are separating and writing m and v square as it is. So it is the work done to display the object under this moving, and since the object is under the moving, this energy can be considered as kinetic energy. So like this we are deriving kinetic energy formula, half mv square. So whenever the numerical it is asked, in this we will be writing this formula, half mv square. Okay, so again I am revising kinetic energy derivation. How you will start? You have to start with this work done equal to F into S. Okay, and we know the formula of the, according to Newton's law, what is the value of F? F equal to m into A. So you are substituting this value in the equation number 1, that is F into S. So you are writing m into A into S. And according to third equation of motion, we know that v square minus u square equal to 2as. So when you are separating s, you will get v square will be here, and what will come down? 2a. So v square minus u square upon 2a, and again we are writing this equation W equal to m into A into S. So in the place of S, you have to substitute this value, v square minus u square upon 2a. So when you will substitute this value, this a and gave it cancel off, and you are separating no value is there, we are writing 1, separating 2 and writing m and v square as it is. Okay, so on the last step you will be getting the formula of the kinetic energy, that is half into m into v square.